All right, hello everyone, and welcome back to another video for the math puzzle crash course. Got another mixed operations problem. We've got quite a few of these right now on the channel. Some mixed operations where we're mixing addition, multiplication together. This one's pretty simple. This might be one of the most widely shared ones that I've seen on Facebook. And for whatever reason, this one seems to generate almost the most incorrect answers that I've ever seen. It's quite stunning, actually. And I'm not sure what the reason is. I don't know if it's because we have the multiplication by zero. I do know some of it has to do with the multiplication being in the middle of this particular equation. But anyhow, what I'd like to do is, if you're not certain on how to do this, you could go ahead and pause the video right now, and then we can come back here in a little bit and work it out together. So if you'd like to pause it now, I'll just shut up for a second and give you a chance. Just hit pause, and we'll come back. All right, so like I mentioned, this is actually a very easy problem. If you remember your, basically it's elementary school mathematics, primary school mathematics. If you remember that multiplication always has precedence over your addition, subtraction, and so on. If you remember your order of operations that you were taught early in school, you will know that you first thing is to multiply 10 by 0. And everybody should know that 10 times 0 is 0. It's not 10. 50 plus 0 plus 7 plus 2 is 59. So it's really pretty simple. It's just, multiply 10 times 0 and then add everything up. And 50 plus, it's 59 is the correct answer. Um, just to go over just a really quick review, similar to some other videos I have, but your order of operations, sometimes it's represented through acronyms. The acronyms aren't necessary. They're really just a memorization tool. And in a lot of ways, I look at them as kind of a really poor memorization tool because too many people will confuse these. But I'm going to put them out here anyway. But some of the common ones are BODMAS, BIDMAS, PEMDAS. There's also BEDMAS. But they really all represent the same thing. They're six-letter acronyms, but they all represent the same four steps of the order of operations. It just depends on if you're from an English-speaking country, you might refer to brackets instead of parentheses. You might refer to orders, indices. Um, and then in North America, PEMDAS is used most often. And the E represents exponents. But really, the exponents, indices, and orders, we're all talking about the same thing. Exponents is not very descriptive because it's really talking more about just exponents, which is like 5 to the third power, where you have, it's the same thing as 5 times 5 times 5. But really, that second step in any of these acronyms, it's all talking about anything that's basically a shorthand or an easier way of writing repeated multiplication. And that actually includes your exponents, which I just mentioned. It includes things like factorials, where you'll have like 5 factorial, which is written like with a 5 and then an exclamation mark, which just means 5 times 4 times 3 times 2 times 1. It's another shorthand way of writing that type of multiplication. It also includes square roots. The square root of 4 is 2. Square roots have precedence over multiplication and division. The third step here, I've got D and M or M and D. It's still the same thing. Multiplication and division have equal precedence. They're solved left to right. Doesn't matter. You just go left to right. Division is the same thing as multiplying by a reciprocal. Addition and subtraction, again, the same precedence. Subtraction is just adding a negative number, so there's no difference. So people, when they say, well, addition before subtraction, Well, they're confused on what the acronyms mean, basically. So again, 59 is the only answer that's correct. I want to stress because I'll see a lot of people say, well, back in my day, we were just taught left to right. Honestly, nobody was taught to ever blindly solve left to right. There's really nobody here that was born before the invention of hardcover mathematics books, and I'm going to show a couple of examples further down. So again, if you already know the answer is 59, you really don't even need to watch the rest of this video, to be quite honest. I'm just providing some additional information here for some people who still doubt that the answer is 59. And believe me, there's a lot of people out there that do doubt the answer is 59. So for those people, I'm going to keep going. For everybody else who understands this and goes, this is like simple. Hey man, you're good. You can move on. Move on to the rest of YouTube. But again, parentheses are just grouping symbols and they're not needed here at all. There you have exponents, factorials, and square roots that I've already mentioned. They're equivalent to shorthand for repeated multiplication, so they have priority over just regular multiplication and division. Multiplication is shorthand for repeated addition. Division's the same as multiplication by a reciprocal, and again, subtraction is the addition of a negative number. So the order of operations convention, some people think, well, who came up with that stupid idea? Well, you can see from these um, relationships between operations, it's not arbitrary whatsoever. There's a reason behind it. It's just there's a lot of people out here there who don't understand that, and they might have grown up just memorizing PEMDAS, or their teacher said, "Remember PEMDAS," or "Remember, please excuse my dear Aunt Sally," and maybe there was no context in that. Maybe the teacher did give them context, but oftentimes the student, forgets all that context too. But there's a real reason behind it, and it's this relationship here that I've just explained. I'm going to go through some of the common wrong answers that I see. 9 is probably the most common incorrect answer that I've seen, and it's because people believe that you just solve left to right, which is not true. The fact is, in order to get 9, you would have to add parentheses to the problem. And I'm showing that right here. You'd have to put parentheses around the 50 plus 10. If you had parentheses around 50 plus 10, you would add those first because all these parentheses, or you might call these brackets if you're from the UK, same thing, but you would do this addition first, but only if it's inside of brackets or parentheses. So yeah, in this case, 50 plus 10 is 60. 60 times 0 is 0, and then 0 plus 7 plus 2 would equal 9. But since there are no parentheses or brackets, the answer is 59. And you should also remember, because one of the biggest urban mathematical myths out there are the people who just constantly, by the droves, will say, well, if you don't have parentheses, if you don't have brackets, you just solve left to right, which is completely false. It's a myth. You don't toss out the order of operations convention just because you don't have parentheses or brackets. Guess what? We don't have exponents. We don't have factorials. We don't even have square roots here. We don't have any of those either. We don't toss out the order of operations because we don't have those. So parentheses around multiplication is redundant and unnecessary. You could put parentheses around the 10 times 0, for clarity's sake. There's nothing wrong with that. But the answer is still 59. It does matter, though, where you put parentheses in a problem. You can't just add them wherever you want. If you're given this problem without any brackets, without any parentheses, you can't just add them anywhere and hope to get the right answer. In other words, if you put them around, say, the 0 plus 7, like you see down here, you're going to get the answer of 122. Why? Because 0 plus 7 must be done first in the parentheses. 0 plus 7 is 7. Uh, 10 times 7 is 70. 70 plus 50 is 120, plus 2 is 122. You completely change the problem by putting uh, parentheses around the 0 plus 7. But again, around the 10 times 0, it's redundant. Um, Another wrong answer, which is really troublesome, is 69. Um, you got to remember that multiplication is solved before addition. A lot of people are coming into this problem and they're adding 50 plus 10 first. And then the other thing a lot of people are doing is they completely forget how to multiply by zero. I'll hear people say, well, if I have 60 donuts and I multiply those 60 donuts by zero, I still have my 60 donuts. But what that individual just did is they've described addition just fine. 60 plus 0 is 60, but they did not describe multiplication. Multiplication refers to how many groups of something you have. If I have 60 donuts and I'm going to put them in bags and sell them by the bag, and guess what? I have 0 bags. Oh my God, that means I can't sell any donuts in bags. I have 0 bags of donuts. It refers to the grouping. So there's a lot of confusion among some people about the difference between multiplication and addition. It's really quite sad to see that. But think about it this way too. If you were going to add 50 plus 10 and then multiply it by 0, well, 60 times 0 is 60 zeros. Well, how many zeros do you think it takes to make 60? 60 times 0 is the same thing as adding up all of these zeros. I painfully typed out 60 zeros here. Now, if I add these all up, do I get 60? No, I get zero. Zero. Okay, so that's completely wrong. Again, hopefully I made my point on this, but fortunately we're multiplying 10 by times 0 and not 60 times 0. But 10 times 0 is also the same as 10 zeros. 10 times 0 is the same thing as adding up 10 zeros. So, if you wanted to, and I've said it before, multiplication is shorthand for repeated addition. So I could take 10 times 0. Let's say, hey man, I can't handle mixing operations. I need everything to be addition or subtraction because that's really just all my brain can handle right now, okay? You could take the 10 times 0 and replace it with the addition of 10 zeros, which is what I've done right here in the bottom of this problem. I've taken 50, I'm adding 10 zeros, then I'm adding 7, and then adding 2. Guess what? You still get 59. So right there, I've shown you again that multiplication is shorthand for repeated addition. That's why multiplication is done before you add. That's why you do not just blindly go left to right, add, subtract, multiply, divide, however you see it. There's a reason behind it. So again, 60 times 0 is 0. 60 plus 0 is 60. There's no 60 times 0 in this problem. Um, 540 is pops up sometimes in the answers. It's a less common wrong answer, but it's still wrong. And the only thing I can think that people are doing here is they're taking 50 plus 10 and getting 60, and then somehow they're just forgetting all about this multiplication by zero, or they think that maybe they think 60 times zero is 60 again. But and then when they get down here, 60 times 7 plus 2, well, for some reason they're somehow combining the 7 plus 2 before they're multiplying, because the only way you're going to get 540 would be if you're taking 60 times 9. So somehow they're combining the 7 plus 2, they're combining all of this up here into 60 and getting 60 times 9 and getting 540. Again, this is wrong. It's just I don't quite understand how people are getting there, but it's really just showing that some people have some difficulties doing some really simple mathematical operations. So I just wanted to point that part out. But again, I mean, here's a book from 1913. I believe it's William Hart, and I can't remember the one or two other authors. It's first year algebra. I believe it's from 1913. And I know what some people are thinking already, but first of all, I'm gonna go over this section here on page 18 where it says the fundamental operations are addition, subtraction, multiplication, and division. Indicated operations are to be performed in the following order. First, all multiplications and divisions in their order from left to right. Then, all additions and subtractions from left to right. And then it goes into some algebra. One of the things I'll always hear from people is, well, you just showed me an algebra book. I didn't take algebra till eighth grade, or I skipped algebra because I did this or I did that. It doesn't matter. The order of operations applies to all, and I'm going to say this again, the order of operations applies to all expressions and equations, regardless if regardless of whether they're algebraic or not. So doesn't have to have it doesn't have to be algebra. It does not have to have a variable in it. And this problem doesn't have variables. It's all numbers, right? It could be treated like an algebraic equation, but it doesn't matter. There's nothing that says, well, the order of operations only applies to algebra. That's another one of those, that's like a second tier urban mathematical myth. I put that kind of far down the chain. It's below the people who think that parentheses or brackets are needed, otherwise you just throw away the order of operations. There's another section of people that have this urban myth about it only applies to algebra. Here's a textbook from the 1950s. It's a teacher's edition, and it clearly goes through this and says, it's got some notes in here about we use this convention to simplify expressions and because students will encounter it elsewhere. And it says parentheses and other symbols of inclusion are the customary means used to make clear the meaning of numerical expressions. However, mathematicians have signed on a rule to fall back on if someone omits punctuation marks, like your brackets, like your parentheses. This rule gives the order to be followed in performing the operations indicated in the expression. The agreement implies, for example, that, and then it's got examples in here, 5 plus 3 times 2. And guess what? This isn't even an equation here. This is an expression. There's no equal sign. You still simplify expression. So there's another camp of people who go on about expressions versus equations, and you don't do this here and you do this there. The only thing an equation is showing equality between expressions. That's the only difference. This is an expression 5 plus 3 times 2. Now, when you use the order of operations on that, here's the example. It actually shows you. Now, it means the same thing as, you can put parentheses around the 3 times 2. It's just showing that to highlight the fact that, the color coding's using for teaching emphasis, but your multiplication has precedence. 5 plus 3 times 2 is the same as 5 plus 6, which simplifies down to 11. So right here, guys, this is not just for algebra. This is not algebraic at all. So, and this is from the 1950s. So I'll hear people say, well, in the 1930s, before they had all this Common Core, new math, or, oh my gosh, I'll hear everything, oh, that must be the Biden math or the Trump math or I don't know, the King Charles math. I don't know where people are from, but people like to create boogeymen for things that they don't understand. And so, like, I'm just trying to point this out, and that's really all I'm trying to do here. So I hope this has been helpful. I know I went on pretty far. I did kind of warn people early on the video that, hey, if you already understood this stuff, you're good, you're fine. But I'll get a lot of arguments and I'll get a lot of disagreements on a lot of these topics. And I wanted to point out my references because I'm in my notes in this video. I have a section where I go through some things like talking about BODMAS, which is the UK acronym that's used a lot. And I've had people come to me and say, well, I saw online where in 1988 it was introduced for the first time. And then what you find out is that links back to a post from Quora. So you've got the people who will go to Quora or Reddit or they'll do a Google search and they don't bother to look and see where the information came from. And that's a real problem. People sometimes have a difficulty citing relevant references, and I can show plenty of examples of that. But check the show notes here and the notes for this video. I've got some links to some other order of operations um, information, and so on. So I hope this video has been helpful for some, and we'll see what happens. But I appreciate everybody who's made it this far. I hope I didn't drive anybody too crazy, but it's kind of an issue here that I see. And but anyhow, hopefully we'll have some other videos coming up. I've got some things I want to go into with algebra. There's some word problems that are kind of fun and tricky that I'd like to toss in here. So, stay tuned. Hope to keep growing this channel, making some more interesting videos. I know when I go back to some of the very early ones, they were pretty bad. I didn't even know how to use DaVinci Resolve, didn't know how to edit. Pretty bad stuff. Someday I probably should go back and replace some of those. And I'm still learning. I'm still, not very talented at that. But guess what? Life is a journey where we're all about learning, right? Hopefully we're all about learning. We haven't closed our minds off to learning. And even me as a grown adult, I'm still learning things every day. Nothing wrong with that. It's great. It's part of the human experience. So I really wish you all a great day and we'll see you in the next video.